Hello everyone, thank you for clicking on my video. I want to create a very quick video guide on fuzzy matching, string matching, and the different contexts that you can apply this in SEO, and also provide some examples of the contexts where you might not want to apply fuzzy matching in SEO, and hopefully with a resource that I will share with you today, you can bridge the gaps a little bit between machine learning theory and machine learning practice, and you can experiment with fuzzy matching straight away. So at the end of the video, I will share with you a template that I created with the help of a few scripts that I found, and the different use cases that I will show you throughout the video that you can apply fuzzy matching in. So let's get into it. But before I begin, I just want to say a huge thank you to Ahrefs for sponsoring not only today's video, but also the article that I have written on fuzzy matching and how you can apply it with the scripts that I will show you. So I just want to say, if you are a small website owner, if you are a little bit unsure what tool to choose when you are just starting an SEO, or if you just want a free tool to use and that is super easy to get around with, I think the Ahrefs Webmaster tool is a perfect tool to get started with. And with that said, let's chat about fuzzy matching. So let's start with the simplest of questions. What is fuzzy matching? Well, fuzzy matching is a form of string matching, and string matching is a machine learning problem that dates back to as early as 1980s. The problem essentially measures the distance between two strings and calculates on the basis of the similarity score between the two strings. Otherwise, it makes an approximation in order to classify whether the strings are equivalent, similar, or very distant. So in a study from Hall and Dowing in 1980s, it says that approximate matching of strings is reviewed with the aim of surveilling techniques suitable for finding an item in a database when there may be a spelling mistake or other error in the keyword. The methods found are classified as either equivalence or similarity problems. In the same study, the authors described that some of the reasons for implementing string matching algorithms are broadly error correction or information retrieval. So to dig in a little bit deeper into those two, error correction might be that you want to correct any misspelling errors or any other errors in the spelling of items in your database, or information retrieval, you want to retrieve all of the items in your database that are similar to the strings that you're entering, but not quite the same. And you want to find all of the ones that exist that might potentially be equivalents of that, but are misspelled differently or are recorded in a different way, but they are essentially the same thing. So error correction refers to a correction point of view, and it is a form of identification of patterns in a large corpus of data, or otherwise retrieve information based on a specified input, finding similarity mismatches, or correcting the error. Now, information retrieval is about providing an input which describes the information we are trying to retrieve from the dataset. Now, there might be two risks with that. The problem might be returning unwanted words, and it might also miss out the words that are required. The similarity problem in string matching is understanding how approximate are two strings, so how alike they are. And let's talk about what actually is measurable within that kind of machine learning model. In programmable information systems, string variations is measured by errors in spelling and typing, and early studies in that field have found that mistaking a letter for another letter is the most common typing error, but also omitting a letter or inserting another by mistake. And with that come also many limitations of string matching when it comes to using those models for clustering, for finding similarity in the sense that we humans consider strings similar based on semantics, based on synonyms, based on any other understanding beyond the simple string matching understanding. And with that, I just want to lunge into the next section of the video, which is the different methods of string matching and understanding what they do. And then we are going to talk about also their limitations as well. So the first method that we're going to talk about is exact matching. Exact matching, or elsewhere referred to as direct matching, is a method that performs direct access matching for the exact pattern or its similarities within a text depending on the location of a character in the alphabetic order. And one very famous algorithm, which is an exact matching algorithm, is the Boyer-Moore algorithm. And this is one of the best known pattern matching algorithms, and it is considered very best in practice. It is designed for the exact string matching of many strings against a single keyword. And here is how it works in practice. You have an input string, a keyword that you want to find similarities for in your dataset. The program loops through the entries and checks for the first characters in the keyword, whether they are present in a given data entry, and then for the length of your input keyword, whether it matches the given dataset entry. And if there is a match, the process is repeated for all the characters in the word until an exact match is achieved. If there is a mismatch, the algorithm looks for the next substring example that has been matched, or otherwise it will discover partial keyword match. So next, another very popular method is distance-based matching, the most prominent of which being Levenstein distance matching and Jarrow. Now, the edit distance algorithm is considered the best algorithm to be used to find the distance between two strings. So essentially, the edit distance between two strings is the minimum number of edit operations that are needed to convert the first string to the second string. And here is how it works. You enter a keyword or otherwise an input in a data set. The program calculates the number of characters shifts needed in order to get from the input to the entry. And a very, very big limitation of this method is that it is based on a simple character distance methodology without any comprehension of semantic similarity between the two keywords and any comprehension between synonyms or otherwise lexicon-based similarity. Anything like that is not considered. And for instance, if we look at the words hard and hand, they would be considered more similar than the words hard and harder, as the latter two would be two additions of characters, whereas the former would need only one replacement of one character in order to become alike. And so from that point of view, in the context of SEO work, whilst this algorithm can sometimes uncover very useful insights in a very, very short amount of time, recovering data from large databases, it can also very quickly miss out on many important keywords that are not falling within the specter of similarity that you provide for the algorithm. So with that, it can be a hit or miss when you're using this type of string matching algorithm in your SEO work. Another type of algorithm that you can use is phonetic matching, such as Metaphone. Now, this type of string matching plays a key role in information retrieval in multilingual environments where you might have diversities in punctuation or writing styles with the same meaning that may be present. However, amongst all of those algorithms, the studies have shown that Metaphone excels in performance compared to other techniques and all types of errors. So for instance, it will best identify errors such as misspellings, letter absences, letter swaps, having additional letters, or any other type of human errors introduced as part of the data entry. And some criticisms of these algorithms are that they are not very productive, as the precision of the output for them is low, and most of them are returning a very large number of false positives, and such algorithms don't detect all close matches, and it's important to adapt the type of algorithm used for the type of database that it is going to shift through. Another popular type of string matching algorithm is n-gram string matching. And n-grams is something that has been very widely talked about in the SEO community and also in the machine learning community as well. It's a very beginner-friendly but also very good technique for very rudimentary NLP analysis. N-grams refer to detecting the occurrences of a fixed set of pattern arrays as embedded subarrays in an input array. This sounds extremely complicated, so let's break down exactly how it works. You enter the keyword "what is string matching" in machine learning as your input, and this can be split into two n-grams, which are also called bigrams, such as what is string matching,
in machine learning.
Or it can also be split into trigrams, like
what is string matching in machine learning.
Of course, you can already see how important it is to remove stop words from your input dataset. So for instance, we already see the stop words that are not really adding value to what we are searching. So for instance, words like is or in, they are not important to the search and the meaning of this query that we are going to try to identify similarities for. And for that, it's quite important before you split and create your n-grams to clean the data that you have and to remove all the stop words. And just to continue the example, we can split it into bigrams, trigrams, 4grams, n-grams, however many we want. And all of these variations are searched for in the dataset, categorized based on the n-gram input, whether it matches or it doesn't match. And this similarity is based on the presence of these n-grams in the dataset entry. N-gram based algorithms are extremely efficient for fast extracting data involving large patterns, and this type of string matching algorithm has a number of different applications, and some of them are for similarity detection, for plagiarism identification. It can also be for keyword or key phrase identification from a large corpus of data, and from the sphere of SEO, that might be what a title or a meta description would match a particular keyword or query that a user has. This is a problem that we are all extremely familiar with. These type of algorithms are also very frequently used to find articles that mention a certain keyword pattern, such as how-to articles, ultimate guide articles, etc. And you might see this type of algorithm working in some of the plugins that you see for related article suggestions or popular articles that match a certain pattern in the keywords, such as how-to guide. Finally, before we move into the practical part, we are going to talk about TF-IDF string matching. Close-in similarity with TF-IDF is a well-established metric for comparing text, and it has been adapted for flexibility matching a query string with values of a single attribute of a relation. And TF-IDF also analyzes the corpus of data as a whole and weighs each token as more important to the string if it is less common in the corpus. Some limitations are that this approach does not take into consideration semantic similarities of the input and the found database entries, and is also not speedy when it is set for high accuracy. And so if we want to summarize what we just talked about, some of the main limitations of these kind of methods are that they do not take into consideration similarities that are outside of string matching. So they only consider the strings as either similar or not similar if any aspect of the string is contained in the database or based on distance. And with that, there is a huge limitation for using these kind of methods for any sort of SEO work that involves a level of semantic understanding. And I will preface this as a big warning for anyone that wants to do things like keyword clustering or any work that would require also some semantic understanding of the keywords outside of the scope of just the strings themselves. So let's talk about what are some commonly used string matching libraries that you might encounter. The first one is Fuzzy Pandas. That is a Python library that is very simple, robust, and lean, and allows you to do fuzzy matching with pandas data frames. You can also use PolyFuzz. Now, PolyFuzz is, in the most general sense, can be used for fuzzy string matching, grouping, and evaluation. It uses different fuzzy matching techniques as a framework. So what is cool about it is it combines many of the different approaches that we talked about. So you can only install one library and experiment with it using the different string matching methods that we talked about. So it has Levenstein distance, which is the edit distance approach. It has TF-IDF character based, and it also has the engram method combined in that library. The framework can be customized to model fuzzy string matching, which is what makes the library not only powerful but is also valuable for string matching tasks. And let's talk about what are the benefits of using PolyFuzz. Well, one is that you can customize the algorithm that you use, and that can happen in just a few lines of code. You can quickly implement different matching models depending on the need of your data, and that can be really valuable when you have a large data set and you want to experiment with different algorithms to see what kind of output you're going to get the best results with. And the second thing is that in addition to that, another benefit is that you can select the edit distance algorithm, especially if you don't want to be hindered by the limitations of some basic algorithms like exact match or Levenstein distance match. There is an abundance of edit distance algorithms that you might want to be using, but we've only covered a very, very small fraction in this article. PolyFuzz allows for that type of experimentation like no other package. I will link a few different tutorials from people that I've enjoyed talking about this topic, and specifically that they've created resources for PolyFuzz, and also that they have allowed you to kind of very quickly get started with matching, grouping, and visualizing models within the single PolyFuzz instance, and that can be used in the model selection process to compare the performance of different models as well. And then finally, a third kind of Python library that I want to talk to you about is Fuzzywuzzy. It is a Python library that uses Levenstein distance to calculate differences between sequences and patterns. It works in the way that we've already explained, by calculating the number of corrections needed in order to go from identified misspelling to the actual entry of the input keyword. Now, let's talk about what can fuzzy matching actually be used for in the context of SEO work. Now, the first thing is that fuzzy matching can be used for internal link opportunities identification, or otherwise finding the similarity between two strings. And two strings can be keywords, it can be titles, it can be URLs. And if you have been paying attention to the theoretical part, you already know which one is going to be more successful than the other two, but we are still going to give it a shot with some of the things that we are going to discuss. So the quickest way to find how similar two strings are is to use fuzzy matching as an app script in Google Sheets or fuzzy lookup formula in Excel. If you want to use Excel, fuzzy lookup is a formula that has already been developed as an add-on, and you can find a great tutorial for using it that I'm going to link below. Essentially, the formula is an advanced version of vertical lookup with advanced mathematics to calculate the probability that what it finds matches up with your search query, which means that the tool will even when characters, numbers, letters, punctuations do not match up exactly. But in a more nuanced way for us Google Sheets fanatics, there's also fuzzy lookup applications in Google Sheets as an app script, and it's easier to install and kind of get going with, and also a little bit more user-friendly, especially when you are trying to share documents online. And now I'm going to show you with the template that I've created for the different use cases for SEO, how you can start doing very quickly string assessments and comparisons of your data. Essentially what you would want to do is scroll your website or use Screaming Frog or any other tool that will enable you to export the content from your pages. You want to copy the sheet and paste whatever you want to compare. So for instance, titles, keywords, headings in column A, and then get your nearest string, that the similar string and the similarity score, in column B. The scores and the similarities, the most similar string, are going to be identified automatically. Hi. Another use case for internal linking, something that I mentioned in a previous article of mine about internal linking, topic modeling, and internal link audits, is that you can find internal page link opportunities in the same topic cluster or across different page groups if you use fuzzy matching algorithms. And based on content extraction of your page, and that could be a Screaming Frog audit, you can also find similar pages to link to. And the recommendation here is to only use this for pages that are somewhat similar in nature in terms of the content structure, such as product pages, or otherwise you might be comparing apples to oranges. This is why I have only mentioned fuzzy matching as an opportunity for identifying internal link opportunities when I was talking about already having clustered your articles in topic clusters and then following up with that kind of strategy to find further opportunities for pages that appear similar based on titles, based on keywords, but they are not already linked. And again, I do want to preface that this kind of exercise should, of course, always be followed up with a manual checkup as any other machine learning that you're going to do, because that is going to make it extremely valuable to ensure that you do have another pair of eyes looking at this data after it gets processed. Another very important note is that this kind of assessment is not going to help you to evaluate the content similarities in terms of semantics or synonyms or any other kind of metric that is familiar to us when we talk about similarity. It is only going to show you the similarities in terms of strings used. And so with that, you want to be very mindful when using this approach and use it in a very controlled way. Otherwise, it might give you some suggestions that would not be the best kind of suggestions to just implement blindly. But it's very fun to experiment with. It's also best to keep the comparisons relatively low in terms of volume, so better compare paragraphs of a page or titles as opposed to the entire content of the page. And whilst this is great for experimentation, it's very important to review the provided recommendations and then sense check them afterwards to ensure that the links made are sensible. So just to kind of go through the process, you're going to crawl your website using Screaming Frog or any other tool that you want to enable to export the content from your pages. You're going to use a custom export from the body of the pages. You're going to copy the sheet, paste the content export in column A and the respective URL for this content in column B. You might want to clean any special characters, you might want to clean any stop words before uploading it. You might also want to resize your rows to the default size and clip the text in column A to ensure that you have a better workflow when using the sheet. In column C, you're going to get your nearest match score. If it's 1, it means that's an issue. That means that you have an exact match, so that would be a duplicate internal page that you have on your website. In column D, you're going to get the nearest similar page or content from the new list, and then you're going to get the similarity score in column E. Now, if you have your in-links report pasted in the separate sheet that is shown on the screen, and you enter a formula in column F, you will also get an assessment whether this link already exists. Now, especially if you're doing this kind of work for a client, it's not going to be the best practice to provide them a list of potential matches only for them to realize that these links already exist. You wouldn't want to link from one page to another a bazillion times when you are just doing internal linking work. So for that, it's quite important to check whether your recommendation that you are providing already exists as part of the internal links on the website. And so with that, you might be left with a few internal linking opportunities that you might have not considered, but you will definitely have some more inspiration when you're doing internal linking work. This kind of experiment should not replace an actual cohesive internal linking strategy where you are trying to promote certain pages or promote the discovery of new queries for those pages, but it is definitely something that you can consider as part of your experimentation when you're doing internal linking work. And now we want to go into the next section of this video, which is fuzzy matching for competitor research. Now you can do competitor analysis of URL and title differences and identifying keyword opportunities. Greg Bernhardt is a creator in the Python SEO space, which I really admire, and I do want to say that he has already created a script and a Streamlit app using PolyFuzz to perform competitive analysis of URLs and other site data such as titles. And the aim of these created tools is to find differences between your ranking URL structure and the use of keywords and those of your competitors, and discover where they are outranking you via the use of the SEMrush API. And this app will also highlight opportunities and quick wins. So definitely, all in all, it is a great tool to use. I am going to link his app and also the blog post that he wrote on this topic, but definitely go and give his app a try. Another thing that you can use fuzzy matching for is redirect mapping and content plagiarism identification. Now, what this will do is essentially evaluate the URLs from redirect mapping outcomes, and you can also perform a check for plagiarism for the content as well. Francis Angelo Rice presented a very nifty URL redirect mapping tool using Beautiful Soup for the content scraping after a redirect project has been executed, and PolyFuzz for analysis to quickly check the content similarity. And the aim of this tool, in the words of Francis, is to find identical URLs in a website migration, and it can be useful when you need to map out the pages from current to old domain to the new domain. Overall, it is an extremely useful app, which I am going to link in the comments below as well. But this type of check can also be done in Google Sheets via the template that I'm sharing today. And in order to do this, you will go to the URL redirection map, and you are going to crawl your website and export the URLs from before the migration and after the migration. You're going to copy the sheet and you're going to paste your old URLs in column A and your new URLs in column B, and automatically you're going to get the match score, the next most similar URL, and the similarity score. Of course, when you are dealing with a redirection process, you will want to map out any inconsistencies, and you will very quickly be able to identify any mismatches of the content. Another use case for fuzzy matching is that you can match 404s to existing content and generate a redirect list. Great, again, legendary technical SEO and Python wizard Greg has created a simple but very effective Python script that uses PolyFuzz to match 404s to existing content and will generate a redirect list using a Python model. For each amazing use case that Greg releases, he also releases the script and the Streamlit app, so I will just refer you to the app and show you how it works on the screen. Essentially, you just upload a CSV of your Screaming Frog crawl with the URL column labeled as address, and then you upload the CSV of 404s from Google Search Console with the URL column titled URL, and again, something that Greg mentions is that this is not recommended for sites with more than 10,000 URLs, just because it's a little bit slow to work with. But again, this is something that you can do for very small sites and kind of doing no-code automation that way. So well done to Greg for being featured twice in this video. I talked a little bit about what fuzzy matching can be used for and what it cannot be used for, and what are the good algorithms to use for keyword clustering and what are some that I would not recommend. And Fuzzy matching unfortunately went into the category of those I would not recommend for keyword clustering, and I do want to say that in general, fuzzy matching can be used for keyword clustering and grouping of keywords in the process of keyword research, or grouping backlinks in the process of backlink research. Leafoot experimented a lot with keyword clustering, and initially he used PolyFuzz for the clustering, and he did state that it is not ideal. It's not the ideal way for doing clustering, and the reasons why it's not ideal were mentioned in the theoretical portion of this video. Essentially, fuzzy matching only does simple shifts between characters, or it only evaluates for the presence of keywords within the other keywords that you're trying to evaluate against, and it doesn't seek out the semantic relations between the words in the cluster. And Lee very nicely states it here. While the job gets done, there are always some head-scratching clusters which I felt the original result could be improved on. Words that shared a similar pattern of letters would be clustered even if they were unrelated semantically. Now, when we are talking about keyword clustering as part of strategy even, it's very important to understand that at that stage it's important for us to find the semantic similarities between keywords as opposed to just clustering keywords together just for the sake of getting the clusters ready. And with that, I think fuzzy matching is not going to be your best friend in that task. With that, I just want to add some final thoughts and additional resources. Now that you know how fuzzy matching works, what are the benefits, what are the limitations, what are the different use cases for SEO, you have all the tools that you need in order to go and test it out yourself. Undoubtedly, it is one of the easiest ways to get started with machine learning, and it has benefits in terms of automation and scalability, but it also has some pretty significant limitations which can make it useful in certain contexts but useless in others, as we have talked about in this video. And in the article that I will share, I've featured the work of amazing creators in the SEO space, but I just want to leave you with some additional learning if you want to dig a little bit deeper into this topic.